If the symbol for iron is written with no charge on it, then that means iron the metal. Iron the metal has no oxidation number. Sometimes we write a 0 up here for the charge or oxidation number because there's no charge on it. Okay? But if we have iron with one of the oxidation numbers here, that becomes iron an ion. It has a charge. It has lost 2 or 3 electrons. Okay? So iron with a 2+ charge is not iron the metal. It's iron 2. If it has a charge, it's an ion. If it has a positive charge, it's a cation. Okay? All right, the other charge that you can find on iron commonly is 3+.
If it's a charge,
all right, so this is not iron, the metal, or iron 2, it's iron 3. Use a Roman numeral in parentheses, no space between the word and the parentheses. And this is also a cation because it's a positively charged ion. So in units 2 and 3, we learned about removing electrons from things like this to create this positive charge. This iron was, or you could think of it as being this atom of iron that lost 2 electrons. And this iron you can think of as being this atom of iron that lost 3 electrons. Okay? So both of these are monoatomic ions.
Does that say cation?
Cation. Cation. These are monoatomic. Since they're both positive, they're not just monoatomic ions, they're monoatomic cations. Okay?
What's cation?
A positively charged ion. An anion is a negatively charged ion. That's correct. Okay? Now, in the last unit, we also introduced you to polyatomic ions. And there were 2 polyatomic ions that I showed you how you could think of them being created. One of them was ammonium. So it's 5 atoms covalently bonded together, but with one more proton than electrons in the structure.
4 at the bottom.
That's ammonia. Ammonium.
Is that 4?
Is that NH plus?
Yeah, that's 4.
4. Down here. So down here that tells you how many atoms are bonded together. Up here is a charge. That's the charge or oxidation
Is
number.
that an O or a? That's an A.
A-M-M-O-N-I-U-M. Ammonium. Okay? I also introduced you to hydroxide. We did the auto-ionization of water, one of the questions on the test. Hydroxide. Hydroxide is one of the polyatomic ions. Since this polyatomic ion has a negative charge, it's a polyatomic anion. Since this one has a positive charge, it's a polyatomic cation. Okay?
Polyatomic cation.
Right. anion, A-N-I-O-N.
That is the one.
Hmm?
That is the one.
Mm-hmm. All right, one of the other references in your test references is this common ions list. One of the other references you're supposed to know is this, know about and know how to use this common ions list. Please open up your test references to the common ions list.
Did you say polyatomic what?
This is an example of a polyatomic cation. This is an example of a polyatomic anion because it's negative.
A-N-I-O-N?
Yep. A-N-I-O-N. Okay? Okay. So in addition to those two polyatomic ions you have to know and know the structure of and know how we get them from Unit 3. If you're given the name of a polyatomic ion, you need to know how to look it up here. Kenya, pay attention up here. Okay? If you're given a formula, you need to know how to find it here. All right. So, in the last unit, we learned how to start balancing, or actually we didn't start in the last unit, I just started teaching it before the test. We already learned how to balance formulas. We learned about balancing formulas in that we got a neutral charge on a compound in the last unit. What we're going to do now is use that knowledge of getting a neutral compound to balance formulas. We're going to start with these ions. We'll start with these kind of ions and polyatomic ions. These monoatomic cations and anions, polyatomic cations and anions. Okay? So let's start with, let's say, sodium. Since I showed you sodium a moment ago. Sodium. Find sodium. Now, if it doesn't have an ATE or IT ending, it's probably an element. IUM usually indicates you have some kind of an element, but ammonium is an exception. Okay, sodium. Find sodium. Find sodium.
I got sodium down.
Okay, find the charge on sodium.
Charge on sodium and
I ain't got time for these.
Hey, can I please partner
Has a 1 plus charge. If you look on your periodic table of oxidation numbers, which you are supposed to have every day, there's a 1 plus charge on a sodium. Okay, if we're talking about sodium, the metal, which I showed you a moment ago, that has a shiny luster, that's an Na. But if we're going to combine sodium, the metal, with something else, it has to become an ion. Most metals, when they combine with other things, form ions to do it. Most metals, when they combine with other things to form some kind of compound, become an ion. So if we're going to put sodium together with something else, we have to have sodium, the ion. So when sodium, the metal, and I used that in the demonstration, when it reacted with the water, it became an ion to do that. Okay? And how do you get a positive charge on an atom?
Take electron.
You give away an electron. You have to give away an electron. So sodium has 1 more proton than the electrons it has. That's how we get that positive charge.
So it's positive.
Ammonium is this thing that's positive. This is sodium, the ion. It is a monoatomic cation because it's 1 atom with a positive charge. An ion is a positively or negatively charged particle. The prefix means positive and the prefix means negative. Okay? Yes?
What do we use hexacyanoferrate for?
We don't use it a lot for anything, but it is used occasionally. Hexacyanoferrate?
Yeah.
I don't know off the top of my head what it's used for. It's a ferrous compound, so I'm assuming, I mean, it's probably used in some kind of metal collection, taking something out of solution. Okay? But that would be a guess right now. Chelating process, maybe. Okay, I would have to go back and look it up myself. All right? Okay. So, we got sodium. All right, so if we're going to put together sodium with something else, let's find a polyatomic ion to put it with. Where are you going to find polyatomic ions? Common ions list. Common ions list.
Oh, right here, what I was looking at.
Mm-hmm. Okay. Let's put it together with manganate. So find manganate. Find manganate. And write its formula. Find manganate and write its formula.
Manganate. Where's Nate at? Manganate. Top right.
Manganate. Write its formula.
Why we didn't study these? I'm talking about like why we didn't have a quiz on like each section, like the S sub.
We did in Unit 2.
That was like
It was Unit 2. It was on the test.
that was on a test, so
Okay, find the polyatomic ion manganate, Kenya.
P sub level and all that.
Kenya, find the polyatomic ion manganate and write it down.
I'm looking for it on here.
You won't find it on there. It's a polyatomic ion.
It's right here.
Yeah, write it down. Now, it becomes very important when you're writing symbols for elements and compounds that you keep the capital letters and lowercase letters clear.
This thing says manganate has, yeah, I was about to say. Two minus.
Okay, so this number down here tells you
How many?
how many atoms or ions you're bonding together. And this number up here tells you
Charge.
the charge or oxidation number. Okay? All right. In the last unit, we figured out how to put these together to make a neutral compound.
Equals 0.
Okay, so right here, if I'm going to put these together, this would be how we would balance the formula. Okay? Balance the formula. That's what this section right here is about. Okay? But down here, we need to figure out how to balance the charges. So we're going to take this 1 plus. We want to add it together with this 2 negative and use coefficients so we can have an equation that equals 0. So you got a 2 here and a 1 there. And that will give us a 0 for that equation. Now this is how we're balancing the charges. Okay? This is how we're balancing the charges here. Well, we have to get the charges balanced to balance the formula. So these coefficients also belong here. Now we don't really need a 1 here because that just means one of those anyway when I write it down. Okay? So we're going to use an arrow to show how we're putting them together. But when we bond them together, we can't use coefficients.